So we'll pick up right where we left off, and let's just review the example again. They gave us an x value here, and they gave us a y value here, and they asked us to find the x value, a missing x value, and we knew a given y value. And they also told us that we had a direct variation by saying that y varies directly with x. So the first step was to find the constant of variation, also called the constant of proportionality. And we use that. Once we have that, we just go back to the equation and substitute in our y value, which is 52, and solve for our unknown x value like down here. So we know that x is 13 when y is 52. Let's look at another example. It says given that y varies directly as x, again they're telling us there's a direct variation, and they tell us the y value and they tell us the x value. We look at it again in a table to organize our thinking, and we want to find the y value when x is 40.5. Again, remember the two-step process. The first thing we need to do is take the y value and the x value that they give us and find our constant of proportionality. So k is y over x. That's not going to change, and that's 3 over 9 in this case, which simplifies to 1/3. So we know that k is 1/3. Now if we remember our equation, y equals k times x, you just substitute in 1/3 for k. And also we know the x value, 40.5, so what we want to do is take that 40.5 and multiply by 1/3, which gives us a y value of 13.5. So when we see that, we know that when x is 40.5, which is what they gave us, our y value we know is 13.5. And we could check that ratio if you just divide 13.5 divided by 40.5, again this y value divided by this x value. It should be in the same ratio as 3 over 9, which should simplify to 1/3. That's one way you can check all of these. All of these, again, remember, should be in the same ratio. When you divide y by x, it should be the same ratio for every set of values, every ordered pair, every x and y value in our situation. So again, let's look at this one. It says, they give us that y varies directly with x, and they tell us the y value is 6 when the x value is -5. So find the y value when x is -8. I'll give you guys a few minutes to copy the situation down and practice for yourselves. So what we should have done is set up our equation, k equals y over x. In this case specifically, y is 6 and x is -5. So we see that 6/5, -6/5, or -1.2. So because we know that k is -1.2, you also could have left it as 6 over -5 and put it into our equation times -8. So we see that negative times a negative gives us positive 9.6. So now we have yet another ordered pair in our table, and if to check, we could say 9.6 divided by -8, and we should come up with a ratio of -1.2. So now let's see what it looks like in a word problem. So it says a car uses 8 gallons of gasoline to travel 290 miles. How much gasoline will the car use to travel 400 miles? Well, how do we know this is a direct variation word problem? Well, you're right, because the car is going to use the gasoline at the same rate while it's traveling, or that's something we have to assume if we're going to call it direct variation. If the rate that the car uses gasoline changes, then this would not work. So for this problem, we have to assume that the car will use gas at the same rate when traveling. So if the car uses 8 gallons of gas in 290 miles. How much will a car use in 400 miles? Step 1, we have to find points. So we see that 8 gallons, and this is 8 gas, should be 8 gallons of gas, and y miles with 290. So what can we do here with this? We're going to take the same approach that we did last time and find the constant of variation. So 36.25. Now what would be the units on that 36.25? I want you in your notebook to write that down in the space right here, what you think the units would be. So the constant of variation is 36.25 what? And that's something we'll talk about when we get back. So 36.25 times x, and again, x is the number of gallons of gas, and y is in miles, the distance that we traveled. So now we have to find out what happens with 400. We put 400 in for y, and then we solve a one-step equation dividing by 36.25, and we get 11.03. Again, we need units here, so what would the units be? Should be gallons of gas. So even though it's a word problem, don't be afraid of it. It's really just a matter of understanding what they're saying, determining if it's a situation that allows for direct variation, defining our variables like they did here. They made a mistake. It shouldn't be gas, it should be gallons of gas. And inputting the appropriate values and setting up the appropriate relationship, solving the equation. So why don't we take a look at this one, and I'll let you guys set it up and solve it. I'll give you about 90 seconds. Alright, so let's check our work now. Set up the table, find the constant. We see 5.95. Again, it doesn't tell us what. So let's put our units on there. We need to make sure we have our units. In this case, it's going to be dollars per hour. And again, this is y is wages. Should be in dollars, should tell us the units. So now to use the equation y equals kx, we know if we worked for $5.95 per hour, and we worked for 30 hours, we would multiply the two to get 178.50, and that would be dollars. So now what does direct variation look like graphically? Let's take a look. So we see that y equals mx plus b, m is the slope, and b is the y-intercept. Some of you have seen that before. We haven't officially talked about it. And the direct variation equation is y equals kx. And we saw that earlier, the b is 0. So what does that mean? Well, that means that when x is 0, m times x is 0. And that leaves us with a y value of 0 also, if b was 0. So here we go, and that just explains what I was just talking about. And if m equals k for the constant and b is 0, the graph will have to go through which point? That's what we're waiting to see. So let's think about that for a second. Every one of these direct variation equations have a graph that always go through the origin. So graphically, that's what we're looking for here. Let's take a look at a few examples. So tell if the following graph is a direct variation. How about this one here? Let's take a look at this one. Is that a direct variation? Our first graph here on the upper left, we see that the yellow line here looks like this, and according to the y-axis vertically and the x-axis horizontally, and we see it is not a direct variation because it's not going through the origin. And here, what do we think? What do we think? And what do we think? Let's just think about those. And we see that this one is yes, it goes through the origin. We see that this one is no. And this one is going to be, well, it goes through the origin. What do we think? Is that direct variation? The answer is going to have to be no, because we're not talking about anything linear. We're talking about something that we haven't even seen yet, and we'll get there. But this has to be no, because we're talking about direct variation as a linear relationship, and we have to think about what it means to be a linear relationship. That's something we've talked about, and we're going to talk about more on Thursday, so I want you to think about that. And let's take a look at these. Direct variation, definitely not, doesn't go through the origin. This one, sure thing. This one looks like it might, looks like a little bit off, and this one's definitely not also. So that's graphically what it looks like. We've looked at what it looks like in the table, and we're going to move on to the next slide in the Smart Notebook slideshow now. Remember, I hope you guys have this all in your notebooks, and if not, you'll have a chance to go back to the wiki to review the slideshow.